Okay, I want to work with combining like radicands a little bit. And basically, when you have terms with radicands or square roots in them, you treat them just like variables. So if I want to add 2 root 3 plus 5 root 3, I pretend that root 3 is a variable, and I keep it just the way it is and add the numbers out in front, what are kind of like my coefficients here. So 2 plus 5, 7 root 3. Or maybe I have 4 root 2 plus 8 root 3 minus root 2, and then plus 7 root 3. Okay, the 4 root 2 minus root 2, it's not going to be just 4. You don't just say, oh, I take away the root 2 and I have a 4 now. You have to think of it this way. 4 minus 1 is 3 root 2. And then 8 plus 7, I get 15 root 3. All right? Just exactly like variables. There's one difference, and the difference is this. Let's suppose I had negative 8 square root of 18 plus 3 root 2. I said root 2 and I wrote root 3. But with a little movie magic here, I just changed it into a root 2. I guess you could say I'm a math magician. Get it? Math magician instead of mathematician. Okay, now, normally you would not combine these because they're not like terms, just like I didn't combine those. However, unlike variables, square roots give you one extra option. 18 can be split up into 9 times 2 plus 3 root 2. 9 is a perfect square. I bring it out. I get negative 8 times 3 is negative 24 root 2 plus 3 root 2. And that gives me negative 21 root 2. Okay, let's do another problem. Let's say that I have cube root of negative 54 x to the 4th plus cube root of 2x and then minus 2 cube root of 16x to the 7th. Alright, first thing I'm going to do, now these don't look anything alike on the inside, but let's see if we can fix any of that. So 54, if I think about that for a little bit, I think that's going to be negative 27 times 2. And x to the 4th has to be split up into x to the 3rd and x, plus cube root of 2x, can't do anything with that, minus 2 cube root, and I think 16 has to be split up into 8 times 2, and x to the 7th has to be written as x to the 6th, x. So the reason I was able to do this, I just have to keep in mind the perfect cubes as I do these problems. So 2 cubed, 3 cubed, 4 cubed, and so on. So I keep those in mind, and I look at these numbers, and as you do more problems, you just start to get experience, and you start to say, oh, wait a second, I remember 54. That's just 27 multiplied by 2. So it's not like magic or guessing. I have an idea. These are some of the numbers that I'm looking for when I'm cube rooting. Just like when I'm square rooting, I'm looking for numbers like 1, 4, 9, 16, 25, and so on. You just have to keep in mind perfect cubes when you're cube rooting, okay? And then always remember the variable, the exponent has to be able to be divided by whatever's outside. So everything has to be divided by 3 if it can be. All right, now, negative 27, I can cube root that and get negative 3 on the outside. The 2 I can't do anything with, but x cubed can be rewritten with just an x on the outside. And left over I have 2x plus cube root of 2x minus, and then here I have 2 times, well, 8 can come out and become a 2. Skip this 2. X to the 6th can come out and become x squared. And then left over is cube root of 2x. So now I have things that are much more similar. So I can keep the cube root of 2x and add the coefficient. So I can add negative 3x plus 1. And then this thing here is going to be 4x squared. Well, how am I going to add that? Because these things aren't the same either. So I guess what I would do in that situation, I would just leave negative 3 plus 1. I would leave it written like that. And then minus 4x squared. And all three of these things are acting as coefficients for this root. So I will just leave them all in a big set of parentheses right out in front. And that is all I can do with that. But still, it was kind of fun, and I hope you enjoyed it.